We have lots of things to do today. We might be a smaller group, but I'm cognizant of the fact that there's lots happening at this time of the year, including report cards are starting. So not always the best time after school. So welcome. We are going to be doing grade 6 today, and we're going to be continuing with the work that we did in June for those who joined me then. And if not, you've had a chance to look at it perhaps already prior to coming to today. If not, I can show you where it is if you need to see. We've been sort of looking at perhaps unpacking the new grade 6 curriculum sort of 2 months at a time. And we were following the year at a glance that we had created. It's not a mandate, not a requirement of in any way, shape, or form. We're just expecting that, whatever we're going to share, we're going to use that format, but you're welcome to use all of the materials whenever it suits best for your own personal planning. So my name is Chris Sarsky. I'm one of the professional designers of professional learning. That's our new title. It's taken me a little while to get used to that. I work with the CART Consortia, and that's sort of central Alberta. And we're going to be unpacking sort of November, December, heading into Christmas, and then we'll meet again just before Christmas, before you leave, and look at some of the pieces there that we can look at for January and February. So as always, we begin with our land acknowledgement. And in a spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse Indigenous, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to its original peoples and the story of creation in a way that history may have forgotten. So as we had talked about in June, when we were doing the planning, the new curriculum is very much a spiral curriculum, which we know, and even more so in the regards that we may have students that have arrived at our doorstep this year in grade 6 that don't have all the background knowledge to each of the organizing ideas that we were looking for. So even more intentional, we were just saying, let's do smaller chunks, make sure that they're really grounded in those smaller chunks, and then move forward as you find your students are ready to handle the material. So when we talk about not necessarily meeting the outcome target at the beginning of the year, that's because we're saying they missed a few things in between. We are going to fill those pieces in, and then we're going to target that outcome at the level that it was supposed to be. So we're going to talk a little bit about math facts today. We're going to talk a little bit about some of the tools that I might use to help make math very visible for the students. And that's kind of my theme for this round of sessions is, can we make it as visible for students as possible? So anybody who's struggling in any way, shape, or form, who maybe it's been our memorizer all along, and memorizers might be a little bit frustrated right now if they're missing some of the background knowledge because they're used to having it all at their fingertips. And so whatever the case may be, the more visible, the more hands-on, the more engaging it can be for the students, the more likely they are to stay with us and be engaged in the lesson, but also to understand and unpack in their own minds what it is we're actually trying to ask them or to learn. So just as a quick reminder, I'm not going to go through this whole thing that we did in June. If you're not sure about how the numbered outcomes documents, any of those pieces work, there was a separate video in unpacking the 3 key documents that we call them. But just as a quick refresher for everybody, the organizing idea houses your big rocks, the big essential learner outcomes sits up there, the concepts that we need to teach our students that are spanning 6 or 7 grades, if it's going K to 6. So 7 grades is a statement, and in that statement are some of the big rocks, the concepts that we need to unpack even further at our grade level. The guiding question was really there for us as the teacher to help prompt our thinking about how we were going to do the planning for this unit. So when I read it and I think about how I would answer that, that should also inform what I'm going to do as far as being planning. A couple of wordings that we should be familiar with or just remind ourselves of. That at any time in the document, if we were to see the word including, then we would want to make sure that we look at whatever comes behind that word including. Any of the bullets that are there Those are pieces that we need to make sure that we include in our lesson plans somewhere. It doesn't have to be all on the same day, it doesn't have to be all in the same time. It does have to be, though, that we include those components in our planning and when we're teaching the students. As opposed to, let's skip down to the bottom, where in here, you grade 6 measurement 1, it uses the word such as. And so in such as, I could use those shapes. I don't have to use those shapes. I could use different shapes if I feel I have a better way of addressing the outcome. That's entirely up to me. So in including, we must have it in there, and it's not the only thing that you have in there. You can add to it, you can put other strategies in. However, when it comes to such as, I have discretion. So I can choose what I want to put in there as the exemplar or how I want to model it for the students as I'm teaching them. And then the last one in between is words that are in brackets. And we see less of them when we get into the upper grades. We see more of those happening in K-3. However, we do have some. And in those cases, the reason that they are in brackets is that is the most correct term for what we're about to teach or we're about to describe to students. But there may be the belief that that word might be too difficult for your students to understand in that format. So the more lay language that appears before it, before the brackets, would be suggestive that that's what we would use instead of that word. So the word would be more for the teacher and the parent as opposed to the student. Now, that being said, there are lots of people that are saying, I'm going to teach that word to the students. I feel strongly that my group is ready to do that. That's your call. Okay, we're going to leave that in your department because you know the students better than anyone else in your class, so you can make that decision for yourself. The progressions, the competencies, and the numeracy and literacy progressions, remember, are part of the 2013 ministerial order, and those never changed, and so they're still part of our planning process. So we always make sure that we can include the competencies, we always make sure that we include the numeracy and literacy progressions, and in that opening video that we did with you in the key documents, we also show you where to find those because they've already been connected to your new learner outcomes and to your cusps that you have within your document. So if at all you can't find those or not sure what that refers to, you could either go back to the intro video or just send me an email. I'll be glad to direct you where you will find those things. All right, the other piece is concepts. So a lot of times people are saying, I'm not sure why we even bother going through all this concept stuff because I'm just going to teach what it says. Well, in actual fact, that's what you're doing is you are picking out what are the big rocks in what it says to teach, and you're picking up the concepts. But we also want to make sure that we understand what are the big concepts, and those big concepts that we're identifying as we start unpacking the curriculum also help to focus our planning, to keep us intentional about where we want to go. And it helps us from, you know, taking those one-offs that go off in different directions and we spend way a bunch of time over here, all good, all interesting, but not necessarily related to what it was I was supposed to teach, and certainly not something that I would assess the student on. So it's a way of us really consolidating what is the thinking that's in this cusp and or whole organizing idea that I'm teaching at my grade level. So a concept, remember, is really a noun. It's a one or two words. That's really what you're looking for. It's not a phrase, not a sentence, not a paragraph, not a definition, just one or two words that really say this is what some of the key ideas are within this statement or this paragraph or whatever the case may be. We should see them show up more than once. So if they only showed up ever once, maybe it wasn't a concept to begin with, or maybe it's such a minute concept that it doesn't have a ton of connections elsewhere, right? So we can look at it from that context as well. I'll give you a good example, a chair. A chair is a word that everybody understands, doesn't matter how old we are. A chair is a concept, it's a noun. But if you went into a furniture store and you said to the salesperson, I'd like a chair, it's very likely that the very first follow-up question that that salesperson has for you is, any particular kind of chair that you would like to have? Oh, yeah, well, I would like to have a bar stool for a kitchen bar for, you know, eating breakfast and lunches and things like that. Okay, so that consolidates the concept for the salesperson what it is we're looking for. And they might say, take this left aisle, go down to the end of the aisle, and you'll find all of those types of chairs down there, and that's what will be there. Well, if that's the case, I've already, as the client, ruled out all those other chairs that are in the room. I've taken all of those concepts and parked them because they're not part of my focus, my lens. And so that's the important piece and the reason why we do what we do. So in this case, when we have the concept of a chair, I see a whole bunch of chairs on the screen right now, but that doesn't mean they're all belong to my grade. My grade happened to be the one that I was looking for something to have breakfast. Your grade, grade 2, maybe they were looking for a living room chair. Grade 5 might have been looking for an office chair. So our learner outcome would have said which chair we were going to study. So that's how we take it from that very broad and come down to the very pointed, in other words, where we focus our attention in our grade, in this case, grade 6. So we start from a broad statement at the top. Think of it as an inverted triangle. The broad base is at the top. That's your organizing idea. The guiding question starts to bring it in a little bit for you and starts to focus kind of where you're going in your grade. By the time I get down to the point or the vertex of the triangle, that's my learner outcome. And it says your chair is. That's what you're studying. Chair was at the top. It was the most broadest term. So those help us to really look at when we're asking students to focus on things. It helps to consolidate their thinking. If you look at these 9 boxes that I have up on the screen right now, just give you a chance just to quickly glance over them. And in the absence of saying anything to you, depending on your personal interest, depending on your background, depending on what you like about math or you don't like about math, you will have been drawn to something in each of those boxes without any direction from me. So some people might have gone to the diagrams. Okay, you might just look at what are the ways that it's been shown. Others of you would have gone straight to numbers. But I never gave you any direction. And that's personal interest of where you go. That's just in your own innate mindset that you have. But if I asked you to look at those 9 boxes again, but this time I'd like you to look at it through the lens of modeling or representation. How is something being modeled or represented in each of those boxes? Without having you all put it in the chat box, I'm quite certain most of you are looking at the illustrations or whatever process that's illustrated there that the student could have been using. Had I said, let's look at each of those boxes through the lens of quantity, most of you will have just ditched the picture and you're going to go straight to the numbers. And some of you are going to look straight at what kind of addition statement it was. Well, how big were the numbers? And others, most of you might have just gone straight to how much was it equal to. You want to know how big were these numbers that they were working with. So again, these lenses, these concepts help to focus where it is we're going to go. We all see the same 9 pictures, but based on the lens I'm asking you to look through, it will determine where you're going to go with each of those. So here's one of our concepts, or one of our learner outcomes that we're going to be looking at today, and that is 6G 1.1, that's coordinate geometry. And students explain location and movement in relation to position in the Cartesian plane. So this is the new grade 7 download into grade 6. All good. Kids are handling this really well. But what I want to do before we even unpack one of these pieces, I want to give you 30 seconds. You don't have to put it in a chat box. You don't have to write it down or anything, but I do want you to take just a minute on your own. If you want to jot them down for yourself, that's fine. What are the concepts that you are seeing from the learner outcome at the top all the way down through those 3 columns? Just jot down some of the words. We'll just give you 30 seconds. We'd normally take way more time. Okay. Start you off at the top. You see some of the concepts already in your learner outcome. Concepts do not just live in the 3 columns. They live everywhere, including if I'd given you the guiding question and the organizing idea, I would find learner outcomes I would find concepts living there as well. So I see location, I see movement, I see position, I see Cartesian plane. So based on that, following kind of that same format, I see that I have all of these, and there's no shortage of them, for sure not. All of these different concepts that are living within just these 3 columns, just this one cusp. So I'm seeing words like translation, combination, horizontal, vertical movement, line of reflection, rotation, movement, amount, turn center, circular path, counterclockwise, clockwise, direction. In the understanding, I see location, change, movement, space, change, location, change, orientation. So these words are very much connected with what I just saw in the knowledge. Let's check out the skill and procedures. I see image, polygon, Cartesian plane, vertical components, horizontal, translation, image. So again, I'm seeing a repeat of a lot of the words, not necessarily all of them from over here, but what happened here created an image over here. So there's a very strong connection between what concepts are living on the left side versus the right side and how they are interpreted in the center. And remember that of the 3 columns that you have, the middle column is your most important column in any of the curriculums. This is not specific to grade 6 math. The understanding is the most important column because it is what I'm measuring, the understanding. Do the students understand this? Not have they memorized it? Can they match it? Fill in the blank. It's do they understand it? Can they model their understanding for me? Can they demonstrate their understanding in a variety of different contexts? That's the importance of that middle column. So these are what we call your concepts of content. This is the content I need to teach them. If I look at the ones that are highlighted in yellow, and I see no shortage of those either, I see the skill and procedures that students need to be able to do. So the skill and procedures, remember the skills and those procedures have to be taught to students and assessed. So I'm not just looking for, I want you to describe something. I'm actually going to look at how well you describe something. Are you able to use the mathematical terms? Do you understand what a description is, first of all? And for any of these, that would be the starting point. If you're asking me to describe, then teach me what does a typically good description look like? Completely outside of the math first. Just what is a description? Because I could use it in LA, I could use it in social, I can use it in science, I can use it everywhere. It doesn't matter. So what is a description? And we have a lot of that work done for you already. If you just want to step students through it so that they all have a common understanding of what is a description. We should not just assume because they're in grade 6 or in grade 5 or in grade 7, everybody knows what a description is. It's kind of like discuss. I want you to turn to your shoulder partner and discuss, and then you give them a task. Well, those discussions could start all right really quickly, but they may not necessarily be on topic. But are students even aware that a discussion, a proper discussion, has 6 or 7 different elements to it? If you gave them a checklist, would they know what those mean? And would they be able to say, yes, I did this in our discussion. Yes, we did this. Yes, we did this. If not, then why don't we just back up for just 5 minutes of time and let's talk about what is a good discussion. Again, there are some resources that we've created for you. All of these skills that we have to teach the students are best taught first outside of math, so that when you start to teach me the math, I'm not learning this skill and the math at the same time. And if I'm a student who really struggles with 2 things happening at the same time, and I'm struggling with math to begin with, then you're talking to me about what is a good description, and then I want you to use it from this context because I just taught you about this particular concept in math. That's a big load for some of our kids. But if I already knew what a description was when it came in, I could just listen, focus, watch, learn, do the math part of it because I already know what a description is. So when you ask me about it, I just need to make sure that I can take the math that I've learned and include it in the description. So I hope that makes sense to everyone. Probably the best example that I give, the quickest one is identify. Identify could be a real surface level teaching pace. There's no gray, depending on how I word it. There's no gray in identify. It is or it isn't. Identify the natural numbers, and I give you a whole bunch of numbers in a circle, and I just say identify them. Well, identify means I could take my finger and I could put it on each one that I think is what you want me to look for. There's no close. Yep, almost. The answer is it's right or wrong. So identify could be a very low level skill, which I need to know what it means. So identify means to go and find, to point out, to see, to explain, to say, to state. Okay. But that I could have learned before I came in here, so that when you are now teaching me about natural numbers, integers, other kinds of number systems, and then you ask me to find only the natural numbers that are on the page, then I can, you ask me to identify them. I know what you are asking me to do. I'm focused now on the math part of it, but I know what to do for identify. So that's a fast way of doing it. Another one would be have them empty their lunch kits on their tables at lunch hour and just say, you know what, we're going to take a few minutes here while you got your lunches out. We're going to see if we can identify. In other words, I want you to see if you can see, locate, point out, hold up a healthy lunch component that you have with you. And you might get some groans where the kids say, I don't have anything that's healthy with me. Oh, okay, well, that's a conversation to have at a different time. But the point is, we want them to identify what are the healthy pieces that they brought with them in their lunch. So it's just a practice outside of math before we get there. So we have, in theory, covered most of September, October already. And remember, if you're following our year plan, if your students aren't ready to move on, then just keep going where you're at. If they're already ahead of that, there's no box that says, do not start November 1st beforehand. If they're ready, move on. If you're confident that they've got what they need, then carry on. But what I did is I took all of the statements that you have from September startup to December. So what are all the skills and procedures that the students would be doing in those 4 months? Now, remember, you're coming back and visiting, because you might say, well, gee, that's not many. It actually is a lot, but it's just one page. You think, well, that's not very much. That's because we keep coming back. We're coming back. So let's just say, for example's sake, my number is I had to go to 10 million. Well, September 1, they're not ready for 10 million. They're not even ready probably for 1 million. They might even be ready for 100,000. I don't know. I don't know what they saw last year in grade 5, right? Everybody's coming to you not necessarily where they would have in a new curriculum. So maybe you start small. Why don't we give them a real sense of accomplishment and say, well, let's master 100. And the reason I pick 100 is not because it's a simpler number. It is. It should be for them in grade 6. But if I can name 100, any 3-digit number, if I can correctly read that number and understand that it's made of ones, tens, and hundreds, then any number that I give them, whether it's in the 100 millions, whether it's in the billions, trillions, it wouldn't matter. If I can read any 3-digit number, I just need to know what house they live in, and I can go ahead and name those big numbers. And some of our kids struggle when we ask them, we write out the number in words and we ask them to write that number. They struggle with well, I don't know where to put this number. I don't know where that goes. I don't know if there's a 0 in here, if there isn't. So starting with 100 is easy. It's easy for them, nice entry point, but also there's a reason for our madness, and that is we want to make sure they're solid. Can they add any 2-digit number that goes into the hundreds? Can they do it easily with regrouping? What if they can't? What if they can't do regrouping? Then what are they going to use as a strategy for adding? Because we're not going to be adding 2-digit numbers forever. We've got to go beyond that. So as I get better at the hundreds, I've mastered it. You are confident. They're flying in that. Everybody's got it. We could move into 1,000. We could move into 10,000. So that escalation and that moving forward is the same outcome. You just keep working on the same outcome. We're just tooling up the number. And the students don't know that they're doing the same outcome. All that we know is we need to get them to where our starting point was for grade 6, or what our goal is for grade 6. So small steps. We don't have to report their ability to do an outcome until June. There is no rush for us to race through and say, I always do the first 6 weeks are always on place value. Well, that could be, but I don't have the background knowledge that I normally would have had coming to you. So I might not be able to do that, right? So when we look at some of these verbs that are in here and some of these skills that the students have to do, there are some that show up more often than others. And I'm not saying we're not going to do them all. But in the very first years, you're unpacking all of that new curriculum. You might want to really be cognizant of the ones that tend to show up more often, tend to be the big rocks. And maybe we are definitely sure that we assess those more than once in a variety of different organizing ideas. And I'm going to start to name some of those for you. You can just jot them down. We don't have them on a slide or anything like that, but just of the ones that we're seeing. And I'm going to say to you right now that some of those ones, most of those ones, not just some, most of them are also the same ones that we're seeing from K to 6 in science. So there would be some legwork already done before the students start doing science 4 to 6. One of them is model at the top. Model also kind of fits very well with representation. That was that opening one that I gave you. So I would write both of those down. Representation is a big one. It's one that shows up frequently, and we would really want the students to be good at that. Describe is another one that we would hang our hat on for a little bit. Compare, compare and contrast, compare, order. This order should be bolded. Those would be words that I would want to include in this year as well. Really be good at those. Relate is another one, but relate could be identify. It really depends on the context it's being used in. So sometimes it's a very surface level one, and other times it's very deep because I have to have tons of knowledge of different things before I can relate and show that relationship that exists between them. We talked about describe. Let's look at determine is another one. And identify, that was that example that I gave you. Identify could be very surface level. It could be deeper, but for the most part, it's pretty surface. Okay, and we're going to do investigate. So investigate means I go through and I try some things out, just like you would in science. So I need to know what is an investigation. Don't just say to me, I want to investigate. Today we're going to investigate what it's like to add integers. What does that mean? Does that mean you're going to show them to me? Does that mean we're going to do them with our hands? So I need to understand what are the steps of an investigation that we're going to follow through. Okay. At the top here, you see one of those sentences has been turned into red. And so I'm not going to go through in other grades, we've done almost the whole page, but the point of the red was some school boards were saying, we are only reporting the learner outcome. And that is the only thing that we're putting on our report cards right from the get-go. So they have these set statements that are on there. But if the set statement says model the sum of 2 positive integers, and I'm into integers, but I'm not finished, then I can't really report on the final statement because I'm not done. And if I have to report on it, then I'm going to have to say you're not meeting. And so some of the conversations we've had with boards is that would almost say that every child is not going to be meeting most of the things if you're going to do it that way. So there's variations happening all over the province. Everybody's doing a little bit differently. But one of the things that we did talk about in the boards that are just using the outcome statement, which is fine because that's what you're supposed to report on. We said perhaps what you could do in your communication with parents, or if you're putting a note down or however you're going to be doing that, is you just take the wording and flip it and just say, so-and-so, Sandra is able to model the sum of 2 positive or negative integers 2. Maybe you had a target for the first report card that when we're doing the integer component, we know we won't be done, but we're going to say that they can add and subtract integers to 100. Okay, I'm just going to pick a number. So they can do 100 or negative 100. So if they can do that, then they are meeting your outcome in that general form because you had a target, and whatever the target was, they got the target and they got it correctly. So they would be meeting. Now, if they kind of fall off the rails between then and the end of the year and they actually never get to the grade 6 level, then at the end, that outcome might be reported that they are not meeting. So I hope that makes sense, but that is one way that you can use language simply to reflect you're doing the outcome, but you're not yet done. And this was the target, and your child has done really well at meeting that target. Okay, without going through the whole thing, I'm just going to zip through some of the things we're going to talk about because then I want to get into some hands-on stuff with you. So we're looking at 6N1, and it's the 0.1 because there were a number of different cusps in the first learner number outcome. So students investigate magnitude with positive and negative numbers. So the operative concept here is magnitude, and magnitude is the distance from zero, and distance is never negative. So whether I have a positive number on a line or a negative number on the line, if I have positive 6 and I have negative 5, the 6 is 6 units away from zero. The 5 is 5 units away from zero, not negative 5 units. So magnitude is simply the length or the distance that we're measuring from zero on our integer line. And whether that line goes horizontally, left and right, or whether it goes up and down, the magnitude would not change. It's always measured from zero. Now, we might say it differently. Like if it was sea level, we might say they've gone, 6 meters below sea level and they've gone 6 meters above sea level, but we still don't say they went -6. So it's always expressed as a positive. Symmetry on the number line extends in infinitely left and right from zero. So in other words, and we'll show that right away here, that if I have a 0 on a number line and I have +1, -1, they're both exactly the same magnitude away from 0. 2 and -2, same. They're mirror images of each other. The only way that I can tell the two images apart is that one has the positive signs and one is the negative signs. But their distances are symmetrical around 0. So if I was the mirror on 0, I would see both things at the same on either side. And the direction relative to 0 is indicated symbolically with that positive and negative. So when I do it with students, and we're going to see a picture of it at tug of war, I need to say to them, there's 2 teams. I need a way to identify each team. So I'm going to call you the positive team, the negative team, with no negative references there. But that's one way for me to name you. That's one way for me to put numbers on a number line and name them so that they look similar positions, but they're going in opposite directions. And then we talk about magnitude with direction distinguishes them from a positive or negative. So when I say that I have a distance of 7 units in a negative direction or 7 units in a left direction, then I know that that's where I'm going to be going. If I have 7 units in a positive direction, I know I'm going to the right, and so on. Okay, so 6N1.2 talks about when students investigate the magnitude of positive and negative. So it's just doing that activity that I just showed you about +6, -7, whatever. Students investigate magnitude of positive and negative numbers when we talk about the difference and the addition of them. So we're going to add them together. What happens when I add a distance of 6 and I add a distance of negative? So I say I'm going to go 5 units to the left and I'm at 6. Where do I end up? So I'll end up at +1. I went 6 units to the right. I'm backing up and going 5 units back in the left direction, and I end up at +1. And so we want them to investigate that on a number line first. So that's where you would start, is just counting on a number line. But then we also want them to be able to do the basic addition. And that comes up very quickly when we do the next section, where they're going to add and subtract integers. And sometimes that's where we lose students because they can't visually understand what it is we're asking them to figure out. Why is +6 add -5 +1? Why isn't it -1? And there are students who they don't craft that or understand that because they can't visualize where it's going. They've never seen a number line. That would be one example. Okay, they have no tools to figure out what it is. So it's a best guess. I know it's a 1. I don't know if it's positive though, and I don't know if it's negative. I'm just going to guess and hope I guess right. And of course, if they're on a pat, they're going to have both those answers. So a strategy to figure that out would be helpful. So 6N2 says solve problems using standard algorithms for addition and subtraction. So there it comes. So I need to use the standard algorithm for addition, but I don't have to start. It didn't say start right away with paper and pencil. It didn't say that at all. It simply said, can you use the algorithm? So I might even start with money. Money's positive. If I take money away, then the money I take away is the negative. So I can put it in context, and that's very much where you start with them, is what is the context for a positive and negative number, so that they're solid in understanding that if I'm above sea level, it would be positive. If I'm below sea level, that would be a negative. I need lots and lots and lots of examples of where do I see positive and negative numbers in my world. temperature gauge, right? That would be another one where they can see positive numbers, they see negative numbers. So those are the kinds of things we're going to start off with very quickly. And then I'm going to actually go into the hands-on because I would really like this whole discussion to be visual for the students. So when we get into 6N 3.1, students analyze numbers using prime factorization and exponents. So as we get into November, we're going to have these numbers that we call prime numbers and composite numbers, which they did in grade 5. Definitely something you want to start with because maybe I don't remember what that is. I might remember that I know prime number is a number that's divisible by 1 in itself. I can tell you that, but it doesn't mean I understand it. So we're going to do an activity to show them what those are. Let's just assume they don't know it. And that would be the way I would start is let's assume they don't remember that. And then I can get into what the factors, the prime factors are of a number. And later I can get into exponents. There is no rush to get through this. It's not a big one, but it's still one that we don't have to race through and say we did it. Students analyze numbers using prime factorization and exponentiation. So what we're talking about there is we're looking at, can I take 64 and break it into its primes? Can I take 32 and break it into its primes? And in the very end, can I take that and write it as an exponent? First, I need to know what a prime number is and a composite number is. And best yet, I even have to actually know what my math facts are of 12 by 12. So you're practicing that at every opportunity you have. You're grabbing teachable moments, whether it's using subitizing cards, using dice, using activities deliberately designed for area to start with, just in building math facts, so that the students are doing it without realizing that they're practicing it. And the better that they get at those, the easier their life becomes as we start unpacking more things. We also had geometry. We said was started in September and October. And in geometry, they're taking shapes and analyzing them through the lens of symmetry and congruency. So congruent means I could take a pattern block, a yellow hexagon, and put it on top of another one, and they're congruent. They match angle for angle, size for size. They're not similar, where they can be one larger, one smaller, same size, same angles. They are congruent, means they are identical in every way. So that's the piece that they're unpacking. But we also said, since you're going to be doing shapes and you're going to be looking to see whether things are congruent, and I need to be able to take those shapes and see if they have any reflective symmetry, all of those pieces, I could use my coordinate grid for that at the same time. So we could unpack geometry and the Cartesian plane at the same time. And once they're good at the shapes, I could put those shapes on my Cartesian plane. And I could figure out what the coordinates of those vertices are. And then I can do the reflections that I need to do, or I can do the translations where I move it to the right 2 and up 5. And what are the new coordinates of the vertices? So I'm really tag teaming the geometry right into the coordinate geometry at the same time. And again, those two, sort of the geometry, coordinate geometry, I would revisit them after Christmas because by that time we would have been done them already. You will be done them, but I can revisit that even on the first day back from Christmas holidays. Just get my brain back into math again. Let's practice a little bit of plotting points on a grid. Maybe they make a cartoon and they give it to a friend where they've labeled what the points are that they have to go to, and can they come up with a diagram? That's a great computing science. Following instructions, can they lay it out so somebody can follow it? So all of those pieces could come together at the same time. We don't need to do a unit called place value. You're going to do place value all the way through and keep bringing it back again. So there's some richness in that, and it's also nicer for the kids not to be stuck into one pigeonhole of one topic that perhaps they're not getting and they're bored of it. At the same time, we were talking about algebra, and I would do that when I'm doing when I'm doing multiplication facts. So students analyze expressions and solve algebraic equations. We're not going to do the equations right away. We won't even throw exponents in. Let's just do something simple, like the order of operations. Start small. They did brackets in grade 5, so maybe I put some addition things in brackets, and then I have an addition and subtraction on the outside, or I have an addition, subtraction, bunt, and then I have the brackets. Like starting really simple and really easy, and then work my way up. And when I start doing the prime factors and I do them with exponents there, well, then I can bring exponents into this. I don't have to do it as a discrete unit all in one. This way, kids will start to see the parallels and that they all fit together. So that's how we kind of intended this to go, is little bits at a time. You decide if you can go faster or slower, however that works for you. Okay, and in December, we're also looking at N4, where students apply standard algorithms to multiplication and division. So do they know how to multiply two-digit number by two-digit number efficiently and quickly using the standard algorithm? If they don't, what do they use? What could they use in your class if I don't get that algorithm? What do I do? Box method, that's a great one. Using my algebra tiles is another one. So all of these different components are coming at the same time. And what am I doing? I'm still practicing my 12 by 12 as I'm going along. So it sounds like a lot, and yet when you start talking to them and saying, you know, let's put this shape on the grid. And then after we've done a little bit of work with them, we can say, you know, if I were to take a line and put it down here, and that was my mirror, where do you think that shape is going to go? So they're going to flip it over. Well, not only have you done a reflection, but now I can say, so what are the coordinates of their new corners? They're not where it was before. What's the reflection going to be? There comes your coordinate geometry. So you're tag teaming back and forth as you go through. Okay, and we talked about this already. So if you're doing lots of hands-on, one of the questions that's been asked is, how do I assess this? And what you need to do is decide what it is that you're going to do with them. And I would say that the more we can do hands-on between now and Christmas, the better for when we come back and we maybe want to do a little bit more paper and pencil. But what does it sound like? What were you hoping to hear after you taught them something and they're engaged in an activity? What are you listening for? What is your cue words to hear that say, yeah, they've got it? Or I heard somebody say that. I heard Danielle say this. I'm not sure, you know, I don't know if that's 100% there yet. I need to go and just maybe mosey over and just ask an open-ended question, not tell them, ask them. And if they can clarify it and they come to that language you were hoping for, good, we got it. Okay, we can move on. So you can't do that with 30 students every day. You can move around and meet all 30 students, but you're not going to assess them to that level. So maybe you target 5 or 6 students each time. And each time you come into a lesson, you say, today, those are the 6 that I'm going to be looking at, listening for, making sure I pay attention to how they responded to questions, when I ask them something, when I walk by, what's their thinking, right? That's all it is. It's formative. We're not marking and giving marks all the time. We want to have formative assessments as we go through. All right, so let's unpack a few things first. So let's look at the first one. We talked about magnitude. We talked about that already. It's a measurement of length, and length is never negative. I'm going to come back to this 6n1 in just a minute. So when I look at even 6n1.2, because there were 2 rows of cusps there, students investigate the magnitude. So we're still talking about length. The sum of any number and its additive inverse. So remember we said that there was a reflective line sitting on 0. There's where the mirror was. +1 is on one side, -1 is the same distance on the other side. They are just mirror reflections of each other. But because they went in different directions, one went to the right, one went to the left, or one went up, one went down. If I was traveling a distance, if I went 1 to the right, and then I look at that -1 and I have to back up and go 1 to the left, where do I go? Oh, I end up at 0. If I was doing the 2s, 2 to the right would mean go 2 to the right, 2 units to the right. A -2 would say go back 2 units. Where do I end up? I end up back at 0 again. I'm always counting right back to where I started. And those 2 numbers, +1, -1, +2, -2, and so on, those are called additive inverses of each other. Additive inverses always give me 0. And hence, they are also called a 0 pair. Now, they talk about you can add 0 to any number. They didn't use the term 0 pair, but as you start reading their wording in the cusp, it says make numbers with multiple zeros added into it. That's really what they're saying, is we've created all these 0 pairs. So we're going to use that term eventually. First, we'll teach them the words additive inverse, but eventually we will get to a 0 pair, especially when we do it visually. We want them to see that. The sum of a positive number and a negative number can be interpreted as the sum of 0, there's that 0 pair, and another number. So when I said, What is positive 6? Add negative 5. 5 plus 1 is 6. So the positive 5 is the additive inverse of the negative 5. Those guys crunched into 0. So there's your 0. And what's the leftover number? 1. That's what they're saying. That's how you read that particular sentence. So again, here's my mirror image. It kind of lays right on the y-axis or the vertical line. We don't even have to call it y-axis to start with. I have a horizontal line. I have a vertical line. I start there. If in the end you want to call them x and y, sure, go ahead and do that, but I don't have to do that right off the bat. So here I have a vertical line, and that could be my mirror. So whatever's on this side of the mirror will be the same distance on this side. If this is 2 units over, then this will be 2 units over, and so on. So really what we're saying is it doesn't matter. For every one that I go to the right, the additive inverse is doing the same amount. Well, every time I line these guys up, what's happening? Well, they just keep canceling each other out and coming back to 0. So that's why we say a number and its additive inverse gives you a 0 pair. That's important for us to remember. Okay, let's skip very quickly first to finding prime and composite numbers. Because I want to, well, no, you know what? I'm going to finish this one. I'll just start on this one quickly. Everything that's in this slide deck, I'll share with you at the end, and you have all these links in here as well. As you see this blue come up on the top, this is going to come up in a couple of documents now that we're sharing with you across the province. This allows you to view the document that we share with you. You can look at the whole thing. And then if you say, I really want this, then click on the blue and it will download it to your computer for you. If you decide, no, this isn't of use to me, then just X out of it and go back to where you were. So let's take a look at a few of the things that we can talk about for integers. So first of all, remember that opening, I don't even know what an integer is. I haven't seen a negative number before. I might have heard about it, but I haven't seen it. So I have to give them a context. Don't just say, you know, all this time we've been telling you that number lines start at 0 and go to the right, but actually they can go to the left too. True, but maybe give me a context to get there. And that would be like a tug of war. So when I teach this concept with students, I go to the phys ed office, I go get the 100-foot rope that we have, and we go outside. I don't care if it's winter or summer, we have a tug of war outside. And I say to the students, I want you to divide yourselves up in a way that you think that the amount of pull is pretty equal here, and they have to have the same amount on each side. Whether they do or not get there, that's usually not the case, but that's okay. It's a good thing for them to estimate and see what they can do. So anyway, we have these kids on both sides. They got the rope, and then I say, everybody know how to work a tug of war? Yeah, what's the rules? Well, we hang a ribbon or something in the middle here. There's my 0. And when I'm pulling, if all things are equal, if these two are pulling with exactly the same force, that ribbon's not going anywhere. And that's the idea behind an integer line. The 1's pulling with the same as the negative 1, 0 stays in place. 2's pulling the same as 2, negative 2, 0 stays in place. So in theory, what's that mirror image on both sides? So the kids love it. Obviously, it doesn't always work out. There's always one that ends up falling in one direction, and that's okay. We can have that conversation, but it's the notion that I'm trying to get to them of what is a tug of war? How does that fit with a number line? So here's the number line you have always seen. We all would always go to the right. Here's my ribbon, and this would be my 0. And then I have the other team, which I called the negative team, and they're pulling to the left. So positive team's pulling against negative team. So and eventually we can unpack that whole notion of what an integer line looks like and how did I get there? It just gives them something to think about rather than just saying, okay, well, you could have just drawn the line here, and for everyone that you have here, you have another one, but so I can tell them apart, I'll call these guys the negatives. Right? Those are all true. But again, if I'm not a math kid, I don't really have a context for that. Yeah, it's true. I can memorize it, but it doesn't mean I know it. So here again, I have positive numbers, negative numbers. 0 is neither positive or negative. The ribbon did not belong to either one team, right? It was neutral. So that's how we can justify that 0 is neutral. So things like in your curriculum, you'll have the word symmetry that comes up. 1 is symmetrical with negative 1, 2 with negative 2, and so on. Magnitude is the distance to a point. So here the distance is 4 units to the left. Additive inverse is a number that's the same number but opposite signs, and they always equal to 0 when I put them together because one's pulling against the other cancels each other out. So those are the kind of key points that we start with. There's no rush to jump into labeling a number line and start counting and doing whatever. Now, I could say to students, what if I took this number line and I put a pin right there and I could swivel this thing? Would it be okay for me to swivel it so that this part of the line goes up here and this part of the line, this part of the line comes down here? I would get a picture that looks something like this. And the answer is sure. I mean, I could turn the page sideways and they'd see that it's exactly the same number line. So now what I'm seeing is I can go up and down, not just left and right. And once I get that doing, and if you actually could get two number lines, cut them out and put them on pins, when you take the horizontal, have them both started horizontal, take one of them, the top one, and slide it up to make it go up and down, then you're already starting to create, hey, did you notice we just made a T or an X here? And we divided our page into 4 pieces. And each one of them has a different piece to it. So that's how you can get to the Cartesian plane, rather than just saying, okay, we can go and drop these, and this is what it is. This is called the origin. Yeah, we can talk about that, but this gives me a context for there. Before I get to that, though, I need to do lots of work about what's a positive. Where's some examples of positive numbers in my world? What are some examples of negative numbers in my world? So these are videos that you can use if you haven't got anything to show the students about where in our everyday lives do we have positive and negative numbers. What about sea level? If the line here is the water level, this is how much I went above the water level, or this is how much I went below the water level. Or maybe this is a mountain. I went this much above the ground level to go up, right? I descend, I came down. How many meters did I come down? So I'm taking that away. So that's eventually going to be our subtraction question. So again, this is another place that you can just use. These are just contexts I'm giving you. And again, you don't have to use them. They're just suggestions. There's one for money. If I put money in my account and I take money out of my account, how much do I have? How do I know how much I have? So one is a positive, one is a negative. Okay, a deposit is positive, a debit is negative. And that's important for them to know. How do they know if they're using a tap card? How do they know if they have enough money? How do they know when it's not enough money, right? Those are the financial literacy conversations. This is an activity that you can share with the students. It's the sandbags and balloons. And they have to use positive and negative numbers in this interaction to keep the balloon from crashing. It's a fun one for them. They enjoy it. But I want to get into these because these are kind of where we're going to hang our hats later after Christmas too when we do equations. So these are other tools that we can use. Now you may have these in your school already. They're called algebra tiles. If you are not a junior high school, then you may not have them because typically, for whatever reason, we seem to think that they should have only started in grade 7 and worked our way up from there. In actual fact, they'd be perfect to start with in kindergarten. I don't need to know that they're algebra tools. All I need to know is that there's rectangles and there's little squares and big squares. I can use them for shapes. They're perfect for that. So in this case, these are called algebra tiles, and they're used to help us to teach integers to start with, but they also help us to teach variables. So in this case, where you see these small rectangles, if I take a look here, I see that that rectangle, both of them, they're exactly the same length, line right up with the square that's there, the big square. And the big square is this long and this high. So the area of this square is this length times this length. This represents an X in math, in the algebra world of algebra tiles. This is another X. So an X times an X is an X squared. So a big, large square represents an X squared. They're not using X squares this year, and they're not using them next year. So we don't need to take those out of the bag, but you need to know what they're all about in case the kids say, well, what do we use this for? I still show them that. I have them line them up and just give them that. Tell them that, if I found the area of a square, what would you do? You go length times width. Okay, well, in this case, when we do that, we get X squared. So I would put these away. These we're going to use when we do equations. And that's where they should come out from grade 3 up. Anyway, they should have been out from that perspective. But we'll put all of the rectangles, the green parts away, and we're going to keep out the little guys, and these are called the units. This is 1, but I want you to look at the unit to begin with. The unit is exactly the same width as the rectangle, just like in base 10 blocks. All right, same idea that the unit is the same width as the rod. Well, that's what's happening here. So this is your x squared, this is your x, this is your unit, your positive 1. On the flip side of every one of these pictures, if I take this and turn all of these over, every one of them is white on the back. So the rule is for now, and I'm going to qualify that in a minute, that anything that's white is negative. So I have a positive side, I have a negative side. Now, that's a rule that I would say 98% of the teachers use to start with, and there's nothing wrong with that, and it's perfect. But it's not a rule in math that says always the green is. That's a legend kind of rule that we have to make sure that students read for legends, because when they write a PAT exam, they will put a legend up saying, probably be in black and white, that they have a shaded in or a dark one. The dark one represents a negative, and the light one represents a positive. They have to look. Like I said, 98% of the time, this is the convention that's being used, and for now, that's what we'll use. Dark is positive, light is negative. So if I keep that, I have my tug of war, then that means that if I was talking about a symmetrical piece, the positive 1 on this side is the same distance as the negative 1 on this side. And I can show that with my blocks, and they're exactly 1 centimeter long. So now I can start to show them that not only were they pulling, and we said it was 0, when I see a white small square and pair it with a red small square, those two are canceling each other out. This is my 0 pair again. And that's significant when we're asking them to do some work in addition. We'll do that in a minute. So here's positive 2, here's negative 2. Those are the additive inverses of each other. They cancel each other out. Each one of these gets to partner with a red one, and that's a 0 pair. So there's lots of opportunities. I'm going to go through this quickly. I would normally have you do this if we were doing it hands-on, but we don't have time to do that. So I would say to students, if I back this up, they won't see this. I'll just say, show me positive 2. So they'll have those little ones on their table. Show me positive 2s. They should show me 2 reds. Show me positive 3. They show me 3 reds. And show me positive 5. Show me 5 reds. And then I might do some negatives, right? So I'm asking them to just give me a model. There's your model of that number, of what it looks like. Now, if you don't have algebra tiles, you probably have colored squares, those integer ones, they call them. Sometimes just colored squares is what they're labeled at. They have lots of different colors, and it doesn't have to be red and white. Make it blue and yellow, any 2 colors. Just blue in our world is going to be positive, yellow in our world is going to be negative, or whatever you decide it's going to be. They just need to have a rule, and every child doesn't have to have the same color. That makes it even richer. As long as they know that the dark, and what are the dark colors? Dark are all these colors, light are all these colors, and this is positive, this is negative. So we practice with students having them show us all of these different ones. Then I can get into addition and say, can you show me positive 2? So I wait until they have 2 reds on their table. And this works well for all levels because the kids can see it and do it. They have to move their hands. So they're engaged. You don't lose too many of them when it comes to these. Positive 3, show me positive 3 below your positive 2. So there's my positive 2, there's my positive 3. So how many do I have all together? I want you to add them together. Well, I have 1, 2, 3, 4, 5 reds. Okay, that's an easy one. Okay, let's try another one. Show me a negative 2, so they'd show me 2 whites. Show me another negative below that, in this case, 1 white. And when they show me that, how many do I end up with? I end up with 3 whites. And I would do a whole bunch of those, a whole bunch of different ones that are all red, a whole bunch of different ones that are all white. And then I would ask them, is anybody noticing a pattern here? Any patterns that are coming up every time I throw out these questions to you? Do you kind of already know what color the answer is going to be? Okay, I'm not going to tell them the rule. If they don't answer it, then just keep going until they finally come up with, oh, I know what you're asking. So every time there's all white, you get all white answer. When they're all red, we get an all red answer. I said, great. What if they were mixed? Like, what would happen if I gave you some reds and some whites? Okay, well, let's try that one. So I get 3 whites on top. I want 2 reds on the bottom. And then I'm not telling them, but I want them to think, do I know anything about every time I see a red that partners with a white? What have I learned about that? That they're additive inverses or 0 pairs. So that means that every time I see a red with a white, That's a 0. It doesn't even need to be there. There's another 0. It doesn't need to be there. And what am I left with? -1. I owed you $3. I paid you back 2. How much do I still owe you? 1. Give them a context before you move on to the next question. Okay, so here I have -6, add a +4. So in this case, I got lots of 0 pairs. What do I end up with? -2. Okay, I'm going to come out of this one because we could be here for quite a while. But there, that slide deck is in there for you to use if you want to use that with your students. I think it needs to be hands-on and not one day of it. Quite a few days of it would be helpful. You can do it with adding and subtracting. Let's go into your primes and composites. I want to make sure that we have a way for a student to realize what is a prime number, what is a composite, before you jump me into find all the primes of a number and write them as an exponent. So I'm going to put this into the chat box. If you have your own device, grab this from the chat and just join me, bring it up on your screen. Unless you already have it saved on your computer, Cuisinart rods. And we're going to do these super quick. So what I'd like you to do, I'm just going to clean up my area here a little bit. So Cuisinart rods, remember, are just rods of different colors. You just click them on up the side and they come up. I don't care what the length of them is. I don't even care if they've ever seen them before. They don't need to. All I need them to do is say, can you tell me which is the longest one right now? And I want you to go grab the longest one. And I want you to build, I'll do one for you, but then I actually want you to do it as quickly as you can. I want you to build layers onto the orange that are common colors. You can't mix and match. So by that, I mean, I'll start with the yellow. I know that 2 yellows, no overlaps, no holes, fit on top of an orange. Now, what are the other colors that fit on there? Go ahead and just drag them on, try them. And if you need more, just click it again and you get more of them come up. So click whatever you need and quickly build an orange. And if you're a little bit faster, then go ahead and grab the dark green one and do the same thing. So do one for the orange and do one for the dark green. Okay, I'll just give you a second to get caught up there. And of course, if the students are doing this on their desk with Cuisinart rods, it goes a lot faster for 1. And 2, they're engaged. They're trying, they're checking, they're putting back what doesn't work and trying another one. All right, so I built my orange one. It doesn't matter what order they're in. It doesn't have to be the same order, color order I have. But in the bottom line is I have all these white ones that are on top and there's 10 of them. So now I can actually ask them how long is an orange. It's 10 units long, in this case, 10 centimeters long. So what have I done? I've shown that I can create different combinations of colors to cover the orange. But what you've actually shown me is how to get the math facts of 10. So if students are struggling in your class with learning multiplication tables, maybe they need to see them first so that they have a clue about what a math fact actually is. It's a way of arranging a number. So yes, grid arrays are one way, but if they're not connecting the array, maybe try this. Okay, I'm not saying that one is better than the other, but here I see I have 10 times 1. There's 10 ones on top. Here I have 5 times 2 because the whites now tell me that a red is 2 long. The whites tell me that the yellow is 5 long, so 2 times 5 or 1 times 10. So now I get a visual, and you could even put this on a whiteboard, do them on a whiteboard, and they just write down what is the multiplication fact that's right beside it. Okay, if I were to do the same with the dark green one, you will have found that the light green fits on top, reds fit on top, and whites fit on top. And in actual fact, 6 whites fit on top because the green is 6 long. So I would have 6 times 1, 3 times 2, 2 times 3, and 1 times 6 if I had filled them all in. Okay, now let's leave those for a minute. Don't take them off your screen. I'd like you to take the black one and very quickly do exactly the same thing and the light green one. So take the black one and the light green one and fill them with any color, same color, rows that you possibly can. Okay. And I know what the answers are. That's cheating, but if you've been playing, you probably found that nothing's really working for you. Only things that fit on top of them are whites. Why? Because this one is 7 long. So this is 7 times 1 is 7, or 1 times 7. This one is 3 long, so 3 times 1 or 1 times 3. Now we know that these are the prime numbers, but I'm not going to say that right off the bat. The first thing I'm going to say is, so what did you notice is in common with all the ones that we've done so far? And usually what they'll say is they all have whites. Perfect. Yep, they all have whites, every one of them. But what's different then? Well, these guys have more colors except white. These guys only had white that fit on them. So the only thing that we could find that worked in the black one, which was a 7, was 1s. The only thing that worked in the green one, which is a 3, is 1. So what do you think? And what some of them will say is odd numbers can only use 1s. Don't correct them right off the bat. Say, good thinking. Let them think that for a minute, because we're going to get them to prove themselves wrong. But they're right. I mean, right now, these look like it's just odd numbers. They also happen to be prime numbers. So we say that, you know what, these actually have a special name. When this happens, and the only thing I can put whites on, we call those prime numbers. A prime number is a number that can only be divided by 1. I see it now, and itself. And you know, it was a wake-up call for me. It was like, Chris, aha, hello. I would be the first teacher to say, I often used to say to students, a prime number is a number that's divisible by 1 in itself. I can't find anything else to go into it. Whereas if I have a number like 12, I can find lots of numbers that divide into that. All good. Until I had a grade 8 student that I had taught for years who I said one day in class, what's a prime number? And he said a number that's divisible by 1 in itself. I said, perfect, excellent. So give me an example. He said, I have no idea. And I said, what do you mean? He said, just gave me a perfect example or perfect definition. He said, yeah, I've memorized that. But he said, I don't know what that means. That was my aha moment. Like, holy, did I make a goof there? I needed to be better at doing what I was doing. So we pulled out tools, and now I would never do them without the tools first. So yes, we say to them that notice the only thing we could put on here was a white robe. That's the only things that, but over here I had reds, I had yellows, I had light greens and reds. So again, I have more possibilities. And these ones we call composite numbers. And composite, if you think of a composition, how many of you play music? Hands up. If it's a composition, it means you put notes together. I'm putting different colors together to create that number. Just give me a context to remember about composite versus prime. Okay, so this helps me now to unpack it. This is the number that we want them to get to when they do their factor trees. So if I give you 32 and I say do a factor tree, at the end, all the numbers when you're done will be prime numbers. That's what we want them to see, but they need to know what that is first before they can actually see it. So now you might want to say, you know what, and I would do this if I was in class, I would say, all the ones that we didn't use yet as a base, I want you to do the same thing. I want you to tell me which ones that are left over are prime and which ones are composite. And some of your students will go, well, that's the 10, this is the 9, that's going to be a prime. That's 8 or 7, 6, 5, 5, 5 is going to be prime. They're just going to go odd and even, right? And I say, okay, well, I need you to prove it to me though. You can't just tell me. I want you to prove it to me that you know a prime from a composite. And of course, when they do the 9, they find out, oops, that doesn't quite work because the light greens, three times three fits on there, and then the ones. So, oh, so it's not just odd numbers. So they have to think a little bit, right? But initially their thinking was good. It's just we need to prove to them. So that part I would do before I launch into my outcome in grade 6, where they're doing the prime and composite and they list all the primes at the bottom. So that's where I would use factor trees. And I would even have little competitions at the board, guys against the girls or whatever you want to do. Send them up to the board. You call out one student, boy and girl at the board, call out 32. They write down 32 and they do a quick factor tree. And they keep going, keep going, keep going, keep going. And then stand back when you think you're done. At the bottom, we should see all prime numbers when they're done. When they can do that quickly and have a little bit of fun with it, then we can show them how to write that as an exponent, but not all in the same lesson. That's just over the top. There's a neat little video here for you for prime numbers as well. Okay, I'm going to just skip through some of these very quickly here because we talked about them. We have talked about the coordinate grid already, so I'm not going to spend time on that. But what I do want to show you is that because it was a download from the junior high, there are some resources here that I put in that you can use, first of all, to teach the coordinate grid. And in this case, you're talking about tessellations. How do I make a similar pattern, a congruent pattern? How can I tile it on the plane? Make some pretty neat patterns. So if you need some ideas to get for that, chapter 8 in this book is all about tessellations. And then here's some examples of how to create them. So that's a fun activity. But first I need to know, how do I plot them on a grid before I do anything? Okay, and here's the plotting on the grid. Sorry, I had those slides out of order. So this is the plotting on the grid. Learn all about it. They got lots of different activities that you can do, lots of translations, reflections, rotations, like all that's in there too. And then I can go into tiling the plane when I go into maybe a star blanket, or I want to do a rectangle in a weird shape or whatever. Okay, we talked about that one already. And we talked a little bit about the notion that students have to be able to analyze algebraic expressions. Let's start small. Let's do order of operations in a small way first, and then build up to it. And you're not going to build up to exponents until I'm even there with the algebra side. So again, that's where you're doing multiple outcomes at the same time. You're just tooling them along and revisiting as you go through. The rest of these slides are money slides that you've seen in the opening intro, but we will come back to these after Christmas when we start getting more into even fractions. We're going to pull up the money parts for fractions and use that. So we'll come back to those coins and we'll use them on a number line. In this document also, and I won't go through any one of the slides, but you have from kindergarten to grade 6, an abridged version of all of the outcomes that get covered in that grade, and anything that's highlighted in color is something that money could do the job. In other words, it could be your prime manipulative to teach the students that component of it. So there's a lot, as you see, that you go through. That money base 10 is what I would use for decimals, for addition, subtractions, grouping, regrouping, place value conversations, values of numbers. All of that can be done with money. There are some videos in here that you can use to show students about money. And if they've never seen how our new money gets made, that's a really aha moment for them. So this is where we'll kind of start after Christmas when we come back. We'll build on a unit fraction, and then we'll build on how do I get them to addition and multiplication, those pieces. Okay, there's some activities that I put in here that you could use to help strengthen my 12 by 12 learning if I haven't got that done. This is also a place value one, but the directions for this are explained for you as a game, as is this one. It's a video. This is a great one. This one gets into area, and I'm not talking about length times width at all. To begin with, they could play this game for 3 weeks. They could do it tomorrow and just do it under the auspices that we're going to practice 12 by 12. They roll a die, they make a rectangle. The whole game is explained here, but that's for the student who doesn't know any math facts. Anybody who knows 0 math facts, not a single one, can do this because they can at least draw a rectangle. So they learn them as they play the game. So that's kind of our goal. I want to go back to the beginning here and grab that one document that we didn't do. Let me just go out of this. And I want to show you the curriculum support document, which is now going to change its name, by the way, just so that you're aware of that as well. And where are we? There. So this is the first document of several that are coming your way. They will be created for each learner outcome in each grade in mathematics, and science is well underway as well. And I do believe that there are some very similar ones for language arts. But let's just focus right now on grade 6 number. You have a number of different numbered outcomes in grade 6. And so this is only the first one. I think there's 8, if I remember correctly, 8 or 6 in grade 6. So for each one of these, you're going to have a document, right? So there'll be different sets for each one. So at the top, you have your numeracy and competency, numeracy and literacy progressions. These are hyperlinked already to Alberta, New Learn Alberta. So you don't have to go and search it, just click them on if you're looking for the link. There's a math planner that's been created. Those will be embedded. They are finished. These are living documents, and we're going to come back and repopulate these on a regular basis. So they're not done, finished. There's going to be more coming, and I'll give you the link for this one as well. The interactive concepts and skills would be your numbered outcomes document, but with all the concepts already hyperlinked to definitions or exemplars, and the verbs as well are in there. So if you don't have that version and you would like that instead, still the same numbered outcomes document, just with hyperlinks in it, then I would download this one and just keep it on your computer. You don't want it print copy because they're hyperlinked, so you want it to be active. And then if you forget anything that we talk about here, in the top right-hand corner is a quick video, which will probably get redone now into how this document works. So this document right now has been called the curriculum support documents. It's now going to be called the curriculum planning and resource document. So it's going to be called CPAR, CPAR. That'll be the acronym for it. So if you ever heard the word CPAR, that's what it is. Okay, we just have to change the name for a variety of reasons. So what do I get in all these documents? Like what's the benefit? None of these are mandatory. This is just for you to use if you wish. That's the only thing that they're there for. You'll start with your organizing idea, your guiding question, and this is the learner outcome for 6N1. Below that, you'll have a brief intro. If you did not watch the earlier videos about what is surface, deep, and transfer for assessment, I would suggest you do that. Here's a super fast overview of what that means. You'll be provided with some sample summatives. Right now, this is one. Is it the end all be all? No. Are there going to be more? Yep, we already have more. So when we do the next iteration of this document and post it, you'll probably see more of them in here. And we're not going to advertise that it's been updated. You just need to check back once they're posted. They're not posted yet, but I will share this one with you today. Once they're posted on the ARPDC site, then you can just go in and check to see if there's anything new that's been added. So for each row of cusps that are in your document, and in this case, you have 3 rows of cusps. I know that because it's to 1.3. You're not obliged to follow them in the order that they appear in your numbered outcomes document. You can do things in any order you want. So if you decided you wanted to do 1.3 first, then you would click it on and it'll take you to that part of the document. You don't have to scroll through. These are all hyperlinked. All right, so in here, what we have are sort of some prerequisite knowledge that they should have prior to me starting this row of cusps. The pre-assessment documents, what are some things that I need to know? And we're going to add some more pieces into this, especially if there's something from the Nelson pre-assessments for those who are using those or leaps and bounds, then will be those linkages in there. Vocabulary, I know I can statements for those of you who use those. And we're hoping to add some pieces for recovery, so students who are struggling a little bit, and then enhancements for our high flyers. What can we do with them? Below that, you will find the knowledge, understanding, skill, and procedure as it appears in your government document. The only difference is that we've given each skill its own row. So I have the information for the knowledge and understanding, but the skill gets its own row and we unpack it with its own illustrative examples, like what does that mean? Because in math, we're finding those skills are already related to content as well. So what does the content look like when it says identify negative numbers, blah, blah, blah? So here are examples. You are more than welcome to use the examples if you so choose in your lessons. If you don't, if you want to ignore them, that's fine too. And then over on the far side are formative assessments, not summative, formatives. This is your check stop or possibilities that you could use just to see, did they get it? Or are we still missing a few things along the way? Okay, so you have illustrative examples, then comes the next one, express. And what does express mean and how does that look? And what are the illustrative examples for that? What are some formatives? And again, there's more formatives coming. So we just keep doing this for every one of those skills that you have. You have illustrative examples doing exactly what you're doing right now. In fact, in those units, if you're following the year plan. And then again, what are some ways that I can show or see that they understand what they're doing? So this happens for each of the cusps that you have in a learner outcome. And below each cusp is a section of resources. Those resources include Mathology, so the most updated versions of what connects to that cusp in Mathology, whether you're using it free from the website or you purchased it in your school division. Math Up, lots of you have Math Up, so where does that fit into this picture? So again, these are not hyperlinked, but these are already identified as these are the matches to the cusp, not the whole learner outcome, to that cusp that you just taught. Existing resources, you have books in your schools. You have Math Focus, Math Makes Sense. So why don't we leverage those? Because they already have examples in them. They already have questions in them. So in wherever I could, I found Math Makes Sense, Math Focus. I gave you the references if they came out of the grade 6 book, because some of the things that you're getting are coming from a grade 7 book. I would strongly suggest that you might want to get a copy of the grade 7 books that are in your division, your school division, and just have one set. You don't need a whole class set of them. You just need one for you that you can use for referencing and using for ideas and for exemplars. The NCETM is a UK version of our math curriculum, and the math team up in Zone 1 gained permission from the UK ministry for them to post those links that they found are good connections to your cusp right in here. They're phenomenal. Like you really, if you've got them, click them on because they're excellent. They're really, really well done. And there'll be stuff in there for your lessons for sure. Additional websites that you can work on or use to augment what you're teaching in this cusp are listed, as are the gizmos. So Karen Bloomhagen has gone in from Explore Learning, and she has already curated all of the gizmos that match your cusp, and they're listed here. So you don't have to go through and take a guess at which ones work. If you've never done a gizmo, you should. Those are interactive opportunities for kids to learn it way better than any worksheet you're ever going to give me. But you do need to do it first yourself so you know what it's all about. And now I see that the second cusp is starting. So I have a whole new set of prerequisite knowledge, a whole new different set of pre-assessments, vocabulary, and it just repeats itself. New sets of illustrative examples. Here's what we're doing right now in the integers that we just talked about. You see the zero pair conversation, etc. So we're hopeful that these will be helpful to you in your planning. If you're not really sure what something means, to help clarify, that you will have those resources for you. So we are looking still for people that would love to help work on these, just on small components of them. The more hands we have on deck, the faster we get these done. We do have the N2s are pretty much ready to go, and the next pieces we're going to do are going to be the coordinate geometries because the grade 5-6 teachers need those, and they're probably half done already. So a lot of these are going to come out fairly quickly. K-3 number is already completely posted on the ARPDC site under the title right now, Curriculum Support Documents, but those will change to CPAR as well. But again, you see the same kinds of things happening at the very, very end. Once you've done all the cusp that you need to do, there will be a section in here, and this is probably not a good example because there aren't any books, but there are a number of resources that we'll put in here that if you're looking to grow your library, you're looking for kids to read stories that link to this cusp or this outcome, then we will put them there as well. So that helps to maybe share that with your librarian, or if you're looking to do that for your in-class library. So hopefully that will be helpful to you as you're going through. And we welcome anyone. We've gotten teachers already to give us feedback where they have examples of learner activities or assessments, or they found a website If you've come across something, share it with us and we will by all means put it into the right place. All right. So we're just trying to make it in the absence of resources right now, just to minimize in your first couple of years to go through it till you feel comfortable. And I mean, at that time, after you've done it a couple of years, you're not going to want to look at these again. It's really just a matter of I need to get my head into the game and I don't know where to look for all this stuff. So maybe this helps save you a little bit of time. All right, so here's the slide deck. Let me put that into, this will be posted. It's just we're having a little bit of a delay in getting them posted. So I just want to make sure that you're not waiting on it if there's things in here that you're teaching and you want to use it right now. So grab that from the chat box. I'm going to stop the share right now and I'll stop recording in case some of you have a question. I don't want you to feel that you're